The ice cracked. That was the first sign. Deep in the Soviet Arctic, in the winter of 1959, a team of engineers stood in temperatures that froze exposed skin within minutes, and watched something move across the frozen landscape that had no name, no category, and no precedent in the history of warfare. The sound it produced was not noise. It was pressure, something that traveled through your chest and your bones and informed your body at a level below conscious thought that you were in the presence of something that did not belong in the natural world. Stay with us until the final machine on this list, because the last one still exists today, still operational, still watching, and what it is designed to do will change the way you think about the world you live in. The first machine on our list does not simply move across terrain, it devours it. It consumes the landscape with a speed and at a scale that genuinely defied every category humans had invented to describe vehicles, and even today, decades after it was built and tested and feared, military engineers and analysts struggle to find language adequate to describe what it actually was. The Ekranoplan, specifically the model designated KM, which Soviet engineers nicknamed the Caspian Sea Monster, was a vehicle that existed in a class entirely its own, a category that had no name before the Soviets created the concept and then built the most extreme possible version of it before anyone else in the world had even seriously considered the idea. It was too fast to be a ship. It was too massive, too physically enormous, too fundamentally heavy to be classified as a conventional aircraft, and it was too terrifying, too strategically consequential, too brutally purposeful to be comfortably described as either one. Built in the late 1960s under direct Soviet military orders, with funding that bypassed normal bureaucratic channels and flowed straight to its lead designer Rostislav Alexiev, the KM measured over 100 meters in length from nose to tail. 100 meters. That is longer than most of the warships that were sailing the world's oceans at exactly the same moment this machine was being tested on an inland sea. It weighed nearly 540 metric tons when fully loaded with fuel, crew, and weapons systems, heavier than most military aircraft carriers of the era. But what made the Ekranoplan genuinely monstrous was not its size. It was the way it moved, and the way that movement made it invisible to every defense system the Western world had deployed. Rather than flying through open air like a conventional aircraft, the Ekranoplan exploited a physical phenomenon called ground effect. When a wing-shaped surface moves at high speed very close to the ground, or to water, or to flat ice, the air compressed between the wing and the surface below generates an enormous high-pressure cushion of lift, far more efficient than the lift a wing produces moving through open air. A vehicle riding this cushion can carry dramatically more weight at dramatically greater speeds, while consuming dramatically less fuel than any comparable conventional aircraft. The Soviets understood this principle and decided, with characteristic restraint, to take it to its absolute and most extreme logical conclusion. The KM was equipped with 10 jet engines, 8 mounted at the nose of the fuselage, 2 at the tail, and when all 10 ran at full power, the machine would accelerate down the surface of the water and rise, smoothly and with terrible purpose, to a height of between 2 and 15 meters above the surface, traveling at speeds exceeding 500 kilometers per hour. At that height and at that speed, it was completely, utterly, operationally invisible to the radar systems of the era. All of them, American, British, NATO, every system deployed in the 1960s, were calibrated to detect aircraft flying at altitude. The Ekranoplan flew below all of it, below the technological horizon of every military in the world that was not Soviet. The strategic implications were immediate and extraordinary. Imagine a craft longer than a football field, loaded with anti-ship missiles, screaming across the surface of the Caspian Sea or the Baltic at speeds no surface warship could match, and no conventional submarine could track, capable of devastating entire naval fleets before anyone on the opposing side received a single radar return indicating something was approaching. The Lund-class Ekranoplan that followed the KM was equipped with 6 Moskva anti-ship missiles, the weapon NATO called the Sunburn, so fast and so maneuverable that Western naval doctrine had no reliable defense against it. The Lund-class, approaching at 500 kilometers per hour from just above the waterline, carrying 6 of those missiles, could theoretically destroy a carrier battle group before the carrier's escorts had time to complete a firing solution. When Western intelligence analysts first spotted the KM via spy satellite imagery in 1967, the reaction inside American agencies was something close to institutional disbelief. Senior analysts refused to accept the photographs were real. They concluded the images had been manipulated, that this was Soviet disinformation, a decoy, an elaborate deception operation designed to draw resources away from real threats. It took months of analysis and multiple independent reviews before the American government accepted that what they were looking at was an actual operational vehicle. It was not disinformation. It was the Soviet Union announcing, in the clearest possible engineering language, that the rules of naval warfare had changed and that Moscow held the new rulebook. The Ekranoplan is the most conventional item on this list. We are only getting started. From the surface of the sea to the edge of space, and few transitions in human history have been as sudden or as brutally consequential as the one the Soviet Union made when it decided that dominating the Earth's surface was insufficient and that it needed to own the sky above it as well. But before the satellites and the cosmonauts and the genuine moments of wonder that the space race eventually produced, we need to discuss the machine that made all of it possible, a machine whose original and primary purpose was not exploration but extinction, the R-7 Semyorka, the world's first intercontinental ballistic missile. One of the single most consequential engineering achievements in recorded human history, not because it was elegant and not because it was subtle, but because it was absolutely, catastrophically, civilization-alteringly powerful, and because it worked, and because when it worked, the world changed in ways that have never been reversed and likely never will be. Developed over several brutal years under the leadership of Sergei Korolev, a man who had survived Stalin's labor camps on fabricated charges of sabotage, who had spent years in conditions that killed the majority of the people around him, and who emerged from that experience not broken, but somehow more driven, more focused, and more terrifyingly productive than almost any engineer who has ever lived. The R-7 stood over 30 meters tall on the launch pad and weighed nearly 280 metric tons at launch, the vast majority of that weight being the liquid oxygen and kerosene propellant needed to generate sufficient thrust to lift the vehicle off the ground and carry it across continents. Its payload was a thermonuclear warhead with a yield sufficient to remove an entire major city from existence in a single moment, and the delivery system was not a bomber that could be intercepted by fighters or destroyed by anti-aircraft systems. It was a missile traveling through the upper atmosphere at velocities measured in kilometers per second, following a ballistic arc that the missile defense technology of the 1950s had absolutely no reliable means of stopping once it was in flight. The engineering challenge of constructing such a vehicle was immense on every axis simultaneously. The rocket needed to generate enough thrust to escape the lower atmosphere, carry guidance systems accurate enough to hit a target thousands of kilometers away with militarily meaningful precision, be reliable enough to constitute a genuine strategic deterrent, rather than an expensive way to destroy your own facilities in a spectacular accident, and be manufacturable in sufficient numbers to represent a real threat rather than a single dramatic demonstration. The Soviets solved every one of these problems, in secret, under political pressure that would have paralyzed most research institutions, with engineers who understood that significant failure might mean not professional consequences but personal, physical, permanent ones. When the R-7 completed its first successful full-range test in August of 1957, the message it delivered to every government on Earth was unambiguous. No city on the planet was beyond the reach of Soviet power. The ocean was no longer a barrier. Distance was no longer a defense. Geography itself had been rendered strategically irrelevant, and then Korolev persuaded the Soviet leadership to do something with it that nobody outside that inner circle had anticipated. He stripped out the nuclear warhead. He replaced it with a small polished metal sphere, about the size of a beach ball, with 4 radio antennas and a simple transmitter inside. On October 4, 1957, a modified R-7 carried that sphere into orbit, and the world heard it beeping from space, and the modern era began. The weapon and the wonder were the same object. The missile designed to end civilization was the identical machine that began the space age. That paradox, brutal, magnificent, and deeply uncomfortable, is the Soviet Union at its most honest and its most extraordinary. And if the R-7 was a statement, then what came next was a scream. Not a message, not a demonstration of capability or proof of concept. A scream directed at the sky, at the West, at the very concept of physical limits. The Tsar Bomba, formerly designated the AN-602, it was a thermonuclear weapon of a scale that had never been built before it existed and has never been equaled since. Detonated on October 30th, 1961, over the remote Novaya Zemlya archipelago in the Soviet Arctic, back to the ice, always back to the ice, to those frozen edges of the world where the Soviets preferred to conduct their most extreme experiments. The Tsar Bomba was the single most energetically powerful device ever detonated by human beings in the entire span of recorded history. The bomb yielded approximately 50 megatons of explosive force, 50 megatons. The device that destroyed Hiroshima in 1945 yielded approximately 15 kilotons, 15,000 tons of conventional explosive equivalent. The Tsar Bomba yielded 50 million tons, more than 3,000 times the power of the Hiroshima bomb. A single device, a single moment. And this was the reduced version. The original design called for 100 megatons. The decision to have the yield was not made from caution or moral hesitation. It was made because Soviet engineers calculated that a 100 megaton detonation might produce atmospheric effects severe enough to damage Soviet territory and endanger Soviet citizens. They made the most powerful bomb in history only half as powerful as originally intended, not from restraint, but from practical self-preservation. The shockwave from the actual 50 megaton detonation traveled around the circumference of the Earth 3 times, detectable by monitoring stations on every continent. The fireball was visible from over 1,000 kilometers away. Windows shattered in Norway and Finland. The mushroom cloud rose to approximately 67 kilometers above the Earth's surface, nearly 8 times the height of Mount Everest, well into the stratosphere, visible from space. The delivery aircraft, a specially modified Tupolev Tu-95 bomber, coated in highly reflective white paint to reduce heat absorption from the thermal pulse, released the bomb on a massive parachute system that slowed its descent for approximately 3 minutes. 3 minutes during which the crew flew at maximum speed directly away from the target zone, knowing that Soviet engineers had calculated their probability of survival at roughly 50%. They knew the odds. They flew the mission. When the device detonated, the shockwave caught the aircraft at approximately 115 kilometers from the blast center and dropped it nearly 1,000 meters before the pilot regained control. They survived. The world they returned to was not quite the same world they had left. If this video has given you a single fact that genuinely surprised you, a like costs you nothing and means everything to this channel, and there are still 2 machines left on this list that most people alive today have never heard of. Not every Soviet machine derived its terror from explosive yield. Some derived it from something more operationally sophisticated and more strategically durable. The ability to project nuclear force anywhere on Earth, continuously, reliably, for decade after decade after decade. And no machine in the Soviet arsenal exemplifies this quality more stubbornly or more completely than the Tupolev Tu-95, the aircraft that NATO designated the Bear. The Tu-95 first flew in 1952, more than 70 years ago, and it is still in active service in the Russian military today, flying operational missions, conducting strategic patrols, being intercepted by NATO fighters over international airspace with a regularity that would be notable even for a modern aircraft, let alone one whose basic design was finalized before commercial jet aviation existed. Most military aircraft have operational lifespans of 20 to 30 years before advancing technology makes them obsolete. The Tu-95 has been flying for over 7 decades and shows no sign of approaching retirement. To understand why, you need to understand what the Soviets were trying to build and how completely they succeeded. The Tu-95 was developed to solve a specific and urgent strategic problem. The Soviet Union needed an aircraft capable of delivering nuclear weapons to targets anywhere in the continental United States from bases on Soviet territory. This required a range of at least 15,000 kilometers, high-altitude operational capability, and sufficient payload capacity for the large thermonuclear weapons of the early 1950s. A pure jet design would have been faster, but the fuel consumption of jet engines at the time made the required range impossible in a single aircraft. The solution was one of the most distinctive engineering decisions in the history of military aviation. 4 turboprop engines, the NK-12, still among the most powerful turboprops ever built, each driving 2 sets of 4-bladed contra-rotating propellers on the same shaft, each set countering the torque of the other, extracting an extraordinary percentage of available engine power as useful thrust. The result was an aircraft that cruised at nearly 900 kilometers per hour, faster than many early jet fighters, while carrying enough fuel to fly over 15,000 kilometers without refueling. It could reach any point on Earth from Soviet territory. It could carry nuclear gravity bombs, anti-ship missiles, and eventually the Kh-55 cruise missile, a subsonic, terrain-following nuclear weapon launchable from hundreds of kilometers away from defended airspace, meaning the Tu-95 remained a genuine first-line nuclear threat well into the 21st century without ever needing to penetrate modern air defenses. The NK-12 engines produced a side effect that became the aircraft's most famous characteristic: noise. The contra-rotating propellers generated a sound signature so distinctive and so powerful that NATO submarine crews reported hearing Tu-95 aircraft through their hydrophone systems while the bombers flew at altitude thousands of meters above the ocean's surface. Fighter pilots who intercepted Tu-95s during Cold War patrols reported hearing the Soviet aircraft's engines through the structure of their own sealed cockpits, over the sound of their own engines running at cruise power. The bear announced itself everywhere it went with a mechanical roar that carried a very specific message. We are here, we are coming, and nothing you build will make us obsolete. 72 years of uninterrupted service have, so far, proven that message correct. Now here is something the majority of people watching this genuinely do not know. While the world's attention was fixed on missiles and bombers and nuclear submarines, while Western intelligence agencies and military planners were focused intently on the Soviet conventional and nuclear arsenal, the Soviets were doing something else in parallel, something that existed past the edge of military technology as it was understood at the time, in territory previously occupied exclusively by science fiction. They were building a weapon for space, not a system designed to be used from space, like a ballistic missile that passes through the upper atmosphere, an actual platform designed to operate in orbit, carrying a directed energy weapon, a laser, capable of destroying satellites and potentially intercepting ballistic missiles during their most vulnerable phase of flight. The project was called Polyus. In some documentation, it appeared under the designation SCIF-DM. Within the classification architecture of the Soviet military-industrial complex, it was among the most tightly held secrets of the entire late Cold War, known in full detail to only a handful of individuals even within the Soviet government itself. The context that produced Polyus is essential. In 1983, American President Ronald Reagan announced the Strategic Defense Initiative, a program to develop a comprehensive spaced missile defense system that would, in theory, intercept Soviet ICBMs before they could reach American territory. Soviet military planners analyzed the proposal and reached a conclusion that was characteristically direct. If the Americans succeeded in building a functional defensive shield in orbit, the entire foundation of Soviet nuclear deterrence, based on the guaranteed promise of mutual assured destruction, the certainty that any American first strike would be met with a devastating Soviet counterstrike, would be fundamentally undermined. The Soviets could not accept this outcome, and rather than building a defensive shield of their own, which would have required enormous resources and represented a posture that Soviet military doctrine resisted at an instinctive institutional level, they decided to build something designed to destroy the American shield before it became operational. Polyus was that something. Assembled at one of the most secure facilities in the Soviet aerospace industry, the Polyus platform measured over 37 meters in length and weighed nearly 80 metric tons, the heaviest single payload ever attempted for orbital insertion at that point in history. It was designed to carry a carbon dioxide laser system rated at 1 megawatt of continuous output power, sufficient in the vacuum of space to damage or destroy satellite systems and engage ballistic missile warheads during the boost phase of their flight. It also carried a secondary anti-satellite weapons system for close-range engagements and an array of acquisition sensors. The launch vehicle was the Energia rocket, one of the 2 or 3 most capable launch systems ever built, capable of lifting over 100 metric tons to low Earth orbit, a machine that represented its own extraordinary chapter in Soviet engineering history. On May 15, 1987, the Energia lifted from Baikonur Cosmodrome carrying the Polyus platform. The launch was successful, the rocket performed correctly, and then a software error in the platform's orientation control system caused it to rotate in the wrong direction after separating from the upper stage. Instead of firing its engines to boost itself into stable orbit, it fired in exactly the wrong direction, driving itself back into the atmosphere, where it broke apart and burned over the Pacific Ocean. The Soviet government never publicly acknowledged what the Polyus was, what it had been designed to do, or that it had been lost. For years it appeared in Western intelligence assessments simply as an anomalous large object launched by a Soviet heavy lift vehicle, subsequently lost, purpose unknown. It was only after the Soviet Union collapsed and the engineers who had built it began, carefully and selectively, to speak publicly, that the full story emerged: a space weapon, a laser cannon in orbit, an attempt to extend the Cold War arms race into the one domain that had, at least in principle, been governed by the Outer Space Treaty of 1967. The failure of Polyus does not make it less remarkable. Knowing how close it came to succeeding, a single software error separating it from operational deployment, makes it considerably more so. And now the final machine, the 6th. The one I promised you at the beginning would not leave you the same way it found you. And before we discuss it, understand this clearly. This is not history. This is not something that was built, served its purpose, and was eventually decommissioned and made safe by the passage of time. What we are about to discuss exists right now, today. In some form, operational, active, doing exactly what it was built to do. And what it was built to do is ensure that no matter what happens, No matter how complete the destruction of the Soviet state, no matter how total the annihilation of every human being with the authority to make decisions, the weapons launch anyway. They called it perimeter. The West eventually called it dead hand. When you understand what it actually is, and what it means for every person alive on Earth at this moment, you will understand why dead hand may be the most accurate name ever given to any machine in human history. The concept behind perimeter emerged from a specific and deeply uncomfortable strategic problem that Soviet military planners confronted in the late 1970s. American nuclear strategy had developed to a point where it genuinely threatened the Soviet guaranteed retaliation doctrine that underpinned mutual assured destruction. American submarine-launched ballistic missiles had become accurate enough and had short enough flight times to Soviet territory that a sufficiently precise surprise first strike, delivered from submarines positioned close to Soviet coastlines, might, in theory, destroy enough of the Soviet command and control infrastructure in the opening minutes to prevent any organized retaliatory response. If the American strike killed the Soviet leadership, destroyed the military command centers, and severed the communications links between those command centers and the missile forces that were supposed to execute the retaliation might never come. The entire logic of nuclear deterrence, the guarantee that any attack would be met with consequences that made the attack not worth attempting, would fail at exactly the moment it was needed most. The Soviets could not allow this, not because they wanted to use nuclear weapons, but precisely because they did not. If any adversary believed, even momentarily, that a sufficiently precise first strike could prevent Soviet retaliation, the deterrent that had maintained a terrible peace since 1945 would begin to collapse. Perimeter was the answer. At its most fundamental level, it is an automated nuclear launch authorization system. It works by continuously monitoring a geographically distributed array of sensors across Soviet territory, seismic detectors capable of registering nuclear detonations anywhere on or near the Soviet landmass, radiation sensors that identify the signatures of nuclear explosions, atmospheric pressure monitors that detect overpressure waves from large detonations, and communication surveillance systems that track whether normal signal traffic through the Soviet military command network is being maintained or has been disrupted. Under normal conditions, perimeter watches, it records, it compares observations against defined parameters. If everything is within normal ranges, it does nothing. But if the sensors detect a pattern consistent with large-scale nuclear attack on Soviet territory, and if simultaneously the system is unable to reach any authorized human commander for confirmation or countermanding instructions, perimeter transitions to its active state. In its active state, it launches a small number of specially designed command rockets. These rockets carry no nuclear warhead. They are not themselves weapons of direct destruction. What they carry is a radio transmitter, enormously powerful, broadcasting on the frequencies used by every nuclear weapons delivery system in the Soviet arsenal. As each command rocket travels on a high ballistic arc across the breadth of Soviet territory, it broadcasts a single specific signal, the launch authorization code. Every missile silo that receives it launches. Every submarine configured to receive it launches. Every bomber on the ground that receives it launches. One rocket, one signal, and then everything. The system was engineered to survive every plausible form of disruption. The command rockets are hardened against electromagnetic pulse. Communication protocols are redundant at multiple layers. The sensor networks are distributed so that no conceivable strike pattern could take all of them offline simultaneously. Perimeter was built to survive the unsurvivable and respond to the unrespondable, to function as a guarantee of retaliation, even in a world where every human being with the authority to order that retaliation was already dead. The engineers who built it were not acting from cruelty. They were acting from rigorous, coldly rational strategic analysis. If the Soviet Union could credibly guarantee retaliation under literally any circumstances, including complete national annihilation, then the incentive to attempt a first strike effectively ceased to exist. The deterrent held. The peace, such as it was maintained not by the hope of preventing destruction, but by the absolute mathematical certainty of mutual destruction regardless of who acted first. The logic, considered purely on its own terms, is sound. The execution is something that Soviet engineers and Western analysts alike found, and still find, difficult to contemplate without a particular quality of quiet, cold unease settling over the conversation. And then there is the detail I mentioned at the beginning, the one that makes this not history but present tense. Perimeter was never fully decommissioned. When the Soviet Union dissolved in 1991, many of its programs were abandoned. Many of its weapons were negotiated away through arms control treaties. Many of its systems fell into disrepair as the resources to maintain them evaporated. Perimeter was not among these. Russian military officials have confirmed in public statements as recently as 2011 that the perimeter system, or a significantly modernized version of it, remains operational. Somewhere, right now, sensors are active, algorithms are running. A machine built on Soviet engineering philosophy is doing exactly what it was designed to do, watching, waiting, and continuously calculating whether the conditions for the automatic end of human civilization have been met. That is not dramatization. That is the documented, confirmed, publicly acknowledged operational status of a system that the Soviet Union built and that Russia has chosen to maintain and modernize rather than retire. And that, more than any missile or bomber or orbital weapon on this list, is the truest and most complete expression of what Soviet engineering philosophy ultimately was. Not the creation of weapons to be used, but the creation of guarantees so total, so absolute, so irrevocable, that using weapons becomes unthinkable. Perimeter exists so that it never has to activate. Its purpose is to make its own activation unnecessary, and for as long as it exists, it is doing exactly what it was built to do. 6 machines. 6 expressions of a civilization that believed with absolute conviction that the scale of your ambition was the only real limit on what you could build, and that no limit was acceptable when the alternative was vulnerability. The Ekranoplan that flew without flying, invisible to radar, faster than anything the sea had ever carried. The R-7 Semyorka that reached for space with a nuclear warhead and accidentally gave humanity the stars. The Tsar Bomba that shook the atmosphere of the entire planet 3 times over with a single detonation and was still only half of what the Soviets had originally designed. The Tupolev Tu-95 Bear that refused to become obsolete across 7 decades and still patrols the skies today with a roar audible through submarine hulls from the surface above. The Polya space laser that came within a software error of militarizing the heavens. And Perimeter, the dead hand, the machine made of logic and contingency rather than steel and fuel, still watching in the dark, still calculating, still guaranteeing consequences that no rational actor could survive. The Soviet Union is gone. But these machines, and the ideas that produced them, the philosophy that refused the word impossible, the engineers who built them under conditions that would have broken almost anyone else, those things did not disappear when the flag came down. They endure. In active service and in museums, in declassified archives, and in operational silos, in the strategic reality of a world still shaped by what the Soviet Union decided to build. If this gave you something new, share it. Subscribe if you have not already, and remember what every machine on this list has in common. The most terrifying thing was never what they could do. It was that someone decided they needed to exist, and then made them real.